Adding and subtracting numbers in scientific notation. Chapter 2, Lesson 2, Part 1. We're going to stick to adding and subtracting numbers with the same exponent in this lesson. So we have some examples here with word problems. So a bakery sold 7.82 times 10 to the 4 loaves of bread in 2010. And in 2011, the bakery sold 4.1 times 10 to the 4th loaves of bread. So to answer the question of how many total loaves of bread did the bakery sell, we are simply going to, because we have the same exponent, put our coefficients in parentheses here, 7.82 times 4.1, and add them together, which is where they get 11.92, and we have 10 to the 4th. It stays the same. But we cannot leave it that way because, again, we need a number smaller than 10 for scientific notation. As you see, we're moving our decimal point now one to the left. So we have 1.192, and now we're adding 10 to the first power. So using the product of power property, 10 to the first power times 10 to the fourth power, we're just adding our exponents, and we get 1.192 times 10 to the fifth power. Again, we cannot leave this 11.92 times 10 to the fourth because this is greater than 10. So I'm moving my decimal point one space to the left, which is where that 10 to the first power comes from. So now I have 1.192 times 10 to the first power, and that 10 to the fourth power that I originally had didn't go away. And now I'm combining these two using the product of power property that you learned in the last chapter. Okay, so we'll do some more practice here. So here we have a subtraction problem using the same numbers. How many more loaves of bread? So again, it's subtraction. So we're simply going to subtract our coefficients. In this case, we are left with 3.72 times 10 to the fourth because we have a number greater than 1 and less than 10. We can just leave this as is. So let's try another example here. Factory A produces 4.7 times 10 to the 8th pencils a year, and Factory B produces 6.8 times 10 to the 8th pencils. So what is the total number of pencils produced by the two factories? First, we're going to simply use the distributive property and put 4.7 plus 6.8, both times 10 to the 8th. So then we're going to add within the parentheses. 4.7 times 6.8 is 11.5 times 10 to the 8th. So we now need to write that back into scientific notation. So I have to move my decimal point one place to the left. So I'm going to write my 10 to the first power. I'll rewrite this number as 1.15 and keep my original 10 to the 8th. So now I'm going to use the product of powers property. I still have that 1.15, and I'm adding my exponents. So I have 1.15 times 10 to the 9th power because 1 plus 8 is 9. So the total number of pencils produced was 1.15 times 10 to the 9th. Again, this 10 to the first power came from the one space to the left. I moved my decimal. So now in part B, they're asking what was the difference. So I'm going to go back and do factory A was 6.8 times 10 to the 8th minus 4.7 times 10 to the 8th. Okay, so now I'm just going to subtract 6.8 minus 4.7 times 10 to the 8th. 6.8 minus 4.7 is simply 2.1 times 10 to the 8th. Again, I'm subtracting within the parentheses. Since 2.1 here is greater than or equal to 1 and less than 10, I can just leave that because this is improper scientific notation. So let's try another problem here. Last year, root vegetable farm produced 6.4 times 10 to the 6 carrots and 7.3 times 10 to the 6 radishes. What was the total number of vegetables? So 6.4 times 10 to the 6 plus 7.3 times 10 to the 6. I'm going to use my distributive property, 6.4 plus 7.3, all times 10 to the 6. That would equal 6.4 plus 7.3 would be 13.7 times 10 to the 6. Again, I can't leave it that way because I can't have a digit in the tens place. So I'm going to move my decimal over to the left 1 point. So I get 1.37 times 10 to the first times 10 to the 6. And then I'm going to combine those here. So I get 1.37 times 10 to the 1 plus the 6, which eventually equals 1.37 times 10 to the 7th. In letter B, how many more radishes than carrots? So I'm going to subtract 7.3 times 10 to the 6 minus 6.4 times 10 to the 6. Distributive property, again, 7.3 minus 6.4 times 10 to the 6. I'm doing the subtraction in my head. 7.3 minus 6.4 equals 0.9 times 10 to the 6. Well, 0.9 is less than 1, so I'm going to have to move my decimal over here to the right. So because I'm moving it to the right, now I have 9 times 10 to the negative 1 power times 10 to the 6 power. And then 9 times 10 to the negative 1 plus 6 becomes 9 times 10 to the 5th power. Negative 1 plus a positive 6 equals the 5th power. So if we have to move it to the right, if we're moving the decimal to the right, our exponent will be negative. So this leads to adding and subtracting scientific notation when we have really small numbers too, or higher negative exponents. The rules don't change. So in this example, the diameter of a hydrogen atom is 2.4 times 10 to the negative 10th meter. And then we have an oxygen atom, 2.8 times 10 to the negative 10th meter. How much greater in diameter they're asking? So that's a difference question. So difference means subtraction. 2.8 minus 2.4. So 2.8 minus 2.4 is 0.4 times 10 to the negative 10th. Just like we did in that last problem, we can't leave 0.4, so we're moving it to the right, which means we have to add that 10 to the negative first power. 10 to the negative first power. And then we're combining negative 1 minus 10, or plus a negative 10, is 4 times 10 to the negative 11th. So the diameter of an oxygen atom is 4 times 10 to the negative 11th power. Another example here, a copper coin, 9 times 10 to the negative 4th. And the thin coating is 1.1 times 10 to the negative 4th meters thick. So they want to know how much it is together. 9 times 10 to the negative 4th plus 1.1 times 10 to the negative 4th. Again, you use the distributive property. We get 10.1 times 10 to the negative 4th. So we need to move that decimal to the left, which would mean we add in that 10 to the first power. So now we have 1.01, 1 minus 4. We get 1.01 to the negative 3rd power. So let's try the example here with a really small number. The length of a large E. coli bacterium is approximately 6 times 10 to the negative 6 meter. The length of a large Salmonella bacteria is approximately 4.5 times 10 to the negative 6 meter. So if a scientist studying both bacteria places them end to end in a petri dish, what is the total length? Total length tells us we're adding, and they set us up here. So we're going to use the distributive property, 6 plus 4.5 times 10 to the negative 6. So 6 plus 4.5 is 10.5 times 10 to the negative 6. We can't leave it as 10.5. We have to move that decimal over to the left. So now I'll have 1.05. We moved it to the left one space. So 10 to the 1 power, or the first power, and 10 to the negative 6. So now I have 1.05 times 10 to the 1 minus 6, which would be 1.05 times 10 to the negative 5th meters. So here in part B, they're asking us to find the difference. So we had 6 times 10 to the negative 6 minus 4.5 times 10 to the negative 6. So we'll use that distributive property again. 6 minus 4.5 times 10 to the negative 6. 6 minus 4.5 is 1.5 times 10 to the negative 6. Since our 1.5 times 10 to the negative 6 is already in scientific notation, we can just leave it as is. We don't have to do any transitioning. Just want to give you a lot of practice here. So we have a plastic film with a sticky surface with a thickness of 4.9 times 10 to the negative 4th meter. And the plastic film was placed over a piece of photo paper. That photo paper has a thickness of 5.3 times 10 to the negative 4th. So how thick is the photo paper with the plastic film added? So we're going to add together here. 4.9 times 10 to the negative 4th plus 5.3 times 10 to the negative 4th. So distributive property, 4.9 plus 5.3 times 10 to the negative 4th. 4.9 plus 5.3 would be 10.2 times 10 to the negative 4th. We can't leave that. We got to move that decimal to the left one space. So I'd have 1.02 times 10 to the first power times 10 to the negative 4th. 1.02 times 10 to the 1 minus 4. And we would finally get 1.02 times 10 to the negative 3rd power here. And how much thicker is the photo paper than the plastic film? That's a difference question. So 5.3 times 10 to the negative 4th minus 4.9 times 10 to the negative 4th. So I'm going to subtract 5.3 minus 4.9. And I would get 0.4 times 10 to the negative 4th. Well, again, I can't leave it that way. Now this time I'm moving my decimal to the right. So that becomes 4 times 10 to the negative 1 times 10 to the negative 4th. Again, it's a negative 1 because I moved it to the right, which is 4 times 10 to the negative 1 minus 4, which finally equals 4 times 10 to the negative 5th difference.